All right, we go ahead and we look at, we are given f of x cubed minus 7x squared plus 6x divided by x minus 6. So the first thing is to find our x-intercepts. So when we find x-intercepts, we take our numerator and set it equal to 0. To make it easier, I'm actually just going to factor this right away. So it has a GCF of x, so I would have x squared minus 7x plus 6 all over x minus 6. And then I'm going to try and factor this trinomial in here. So I will have x multiplies to 6 and adds to negative 7. So negative 6, negative 1, all over x minus 6. So when I set my numerator equal to 0, I would have x equals 0, x minus 6 equals 0, and x minus 1 equals 0. So one answer is x equals 0. Then I would add 6, so I have x equals 6. There's my other x-intercept. And then this one I would set equal to 0, so I get x equals 1. Okay. Before I look for vertical asymptotes, I always look for removable discontinuities. Removable are the ones that cancel out. So since it canceled out, I actually have a removable. So I have a removable at x equals 6. Then vertical asymptotes are whatever's left in the denominator. Nothing is left there. So this time I do not have any. So there's none. Horizontal asymptotes come from doing leading term over leading term. So I would go back to the original defined horizontal asymptotes. So my biggest degree in my numerator is x to the third. And my biggest degree in my denominator is x. X to the third over x to the first reduces to x squared. Does x squared have any horizontal asymptotes? No. So there's actually none for the horizontal asymptotes. Now let's go ahead and find our limits. Okay. In this case, we are going as we go to infinity. So once again, we do leading term over leading term. So it's very similar to our horizontal asymptotes. We would have x cubed over x, which reduces to x squared. If I plug in infinity and I square it, I'm still going to infinity. The other way you guys could check this is you'd say to yourself, well, what does x squared look like? It looks like this. That's how it behaves. And as I go to the right towards infinity, I'm going to continue to go up and up and up to infinity. Okay. We'll do the same thing as you go to negative infinity. We'd be left with x squared. So I'd have a negative infinity squared, which is positive infinity. Or you could go ahead, and as I look to the left, this will continue to go up and up, so also infinity. Now my limit as x approaches 6. This time, I can't plug 6 into my denominator, but you guys see how it's simplified? So I can use my simplified function in order to find this limit. I don't need to graph it in this case. Since it's a removable, there's a hole going on there. So it's really my limit as x approaches 6, and I'm using the simplified version, so it's really x minus 1. So I'd plug in 6. So I'd have 6, and then I'd have 6 minus 1. So it's 6 times 5, which is 30. And as I approach 6 from the left, it's going to be the exact same function, same thing. So this would also be 30. So that is example 4.